then we will
Sundar sir, voice is not. Sundar sir, voice is not clear, Sundar sir.
sun generator. This is sun generator. With 800 wave connectors, 800 wave connector, conductors, wave connectors, and running at 600 RPM. Running at 600 RPM. Supplies a load of 15 ohm. Supplies a load of 15 ohm resistance. 15 ohm resistance. Okay. The armature resistance is armature resistance is 0.282 ohm. Armature resistance is 0.28 ohm. Field shunt field resistance is 240 ohm. Resistance is 240. What you have to determine? Armature current next one induced EMF finally what is the flux per pole? What is the flux per pole? Flux per okay. So now we have to solve the so I already told that so you have to good practice to given data. So given data so it is a 10 mole. So P equal to 10. Next one. It is a sun generator. The number of conductors is 800. That equal to 800. And it is wave connector. So wave connector. To mention wave. So A equal to 2. So wave connector is equal to 2. So they are given the speed and standard RPM.
Sundar sir.
Standard RPM.
Sundar sir, your voice is breaking, sir.
They are given the load of 15 resistance. So resistance load. So we can make it as RL 15. Next, armature resistance 0.28 ohm. So RE equal to 0.28 ohm. Next, shunt field resistance is 240 ohm. So R is equal to 240. So I have written all the data. What are the given data? Before I am finding the values, I have to draw the circuit. Then I have to take the equation. Then I have to substitute the formula. Okay. So it is a front field. Okay. So the field and armature are parallel. Field and armature are parallel. So this is RS sketch. This is RA. Okay. So A1, A2, F1, F2. So the current going through this is IA. The current going through this is ISH. Okay. This generator. So here it is not a generator. So the current will flow from this generator. So it is supplying a load. So it is supplying a load RL. They are given RL equal to 15 ohm. So the current going through this is IL. So this is the diagram of the particular problem. Now we will find one. So first thing is we will find armature current. Before finding the armature current, this current is going through ISH, this current going through IL. This sum of these two currents is equal to IA. First you will find this. IA equal to IL plus ISH. IA equal to IL plus ISH. Because generator only supplying all the power. So this current is divided into two here, IL plus IL. So you have to find IL, you have to find ISH. Then you have to add these two values to get the R. So IL, what is IL? V divided by R. So they are given voltage. I have forgot to write the voltage. Forget to write the voltage. So the voltage is 200 volts, 240 volts. Is 240. Since all the circuits are in parallel, okay. So they are given the voltage is 240. 240. So it is available here also. Here, there is some 240 volt plus this voltage drop will be there. There is some voltage drop in the armature. So first we see what we want. So I want to find the current, armature current. Now to find the armature current, I should know what is the field current, what is the load current. So when you add these two values, you get the armature current. So I am finding the load current. So voltage is given 240, RL is 15. So 240 by 15 is equal to what? 15 amps. So IL equal to 15 amps. Next I will find the ISH. So ISH is V by RSH. It is equal to V is 240 once again. RSH is 240 once again. It is 1 amp. Now IA, you can find the IA. Equal to IL plus ISH. 15 plus 1, 17 amps. Okay. So first I have written the given data. Next I draw the subfield connection. So generator only supplying all the power. So every load, it is a load, is supplied to the generator. So IA current is equal to sum of the all the currents. So I am finding the individual current. So voltage given, resistance also given. So I have find IL and ISH, and I have sum of all these currents. I get the IA. So IA is nothing but armature current. They have found the first value. Okay. They found the first value. Next one is induced EMF. So all of you write down this problem. So after writing the problem, you put completed in the problem. These problems are very important. One important question is EMF equation, or otherwise a problem they will ask. Write down the problem. It is very important. So whether it is visible, I think it is visible here. So what about you? Is blur on the
Sundar sir. Sundar sir.
we finish this step, we move to the next step. So now we have finded the armature current. Next we have to go to the induced EMF. What is a generator? So all the load are supplied by this generator. So all the voltages are current are developed here only. So remaining things are load only. So they will not generate any power. Here generator. Motor, the connection is different. Okay. So this current only divides into two here. So I am adding IL to the IL first. I am finding IL, I am finding ISH. IL is V by RL, ISH is V by RL. So V you know RL also given, RL is given. So you find the current. So add these two currents, I am finding the IA which is the armature current. So I have found only the first step. So if you finish the problem, I will go to the if you have any doubt, you can ask then and there. So this model is very easy when compared to the first model. So first model we have building circuits. They are only formulas. You have to apply the slightly and you have to apply. The formula is correct, answer will be perfect. Yes. The first model we have done so many equations and we have to solve. I hope you get the first column so that I can move to the next step.
Sundar sir.
So we know the formula for induced EMF equal to pi Z10 by 50 into V by E. Now in this formula pi you have to find out that you know n also know T constant P know 10 A equal to. Since pi is not known, you cannot apply this formula. For going to the circuit, so we can find that T. So Eg equal to V. This voltage is 240. So there is some resistance here, RE. So IA into RA is voltage drop. So EG equal to the generated EMF is equal to V is voltage 240. V plus IA or IA. Okay. So generated voltage, after generating the voltage, there is some voltage in the armature resistance, voltage drop. That is IA or IA. So that voltage drop plus this voltage will give the total EMF generated. So total EMF generated is equal to total EMF generated. So it is generated. So E equal to voltage, terminal voltage we know V plus that voltage drop in the armature. Voltage drop means V equal to IR. So I is IA, R is R. So V plus IA. This is another formula for EMF generation. EG equal to V plus IAR. This is for sun generator. If it is common generator, the formula changes. So this formula is not constant. This formula is based on the type of connection. So only I not explaining the morning. The formula is based on the connection. What you are connecting. For the sun generator, EG equal to V plus IAR. If it is series generator, formula is different. Okay. I will explain in the series connection also. Okay. Total EMF generated is equal to V plus IA. So V you know that 240. So IA they have found that it is 17 amps. REM they have given 0.28. The sum itself they have given 0.2. So 240 plus 2.8 to 1.7.
Sir, your voice is not clear, sir.
2.76. So it is equal to 244.76. Okay. So total EMF generated I have found out. Now I am using this formula to find the phi. Okay. So I know the generated EMF 244.76. Phi I just so pi into 800 n 600 by 60. P is 10. A is 6. So now we can solve it and we can find the phi. 50 get cancelled. It is 10. I think 10. This becomes 5. So 44 by 6 is equal to 5 into 800 into 5, 400 is 4,000 into 10, 40,000. Now you have to find the value of pi. Pi is flexible force. So pi into 40,000 is equal to 244.76. So pi equal to 244.76 by 40,000. We have to find the value. It is equal to 0.006119 Weber. So it can be written as 6.119 milliweber. So this is 5 plus 4. This is EG, back generated EMF. So IA we have already got. So for this problem, we have to first know the circuit, whether it is a sun generator or series generator. Hello. இப்ப கேக்குதா? ஹலோ.
எஸ் சார், கண்டினியூஸா பேசுங்க சார், ஒரு லைன் கண்டினியூஸா பேசுங்க.
So here Z equal to 800, A equal to 2, N equal to 600,
ஓகே சார்.
RL equal to 50.
ஓகே.
Yes. ஹெட்செட்ல ஏதோ பிரச்சனை இருக்கு. Okay. So I am taking the same problem. So from the given data, so first you draw the diagram. So it is a sun generator. So sun generator means armature and field connection are in parallel. Okay. So that is known as sun generator. So here we have connected a load. So the load is after this connection. Okay. The load means 15 ohm, voltage is 240 volt. So since it is parallel connection, here also 240 volt will be available. So everything is supplied by the generator. So this armature current is supplying all the currents. Okay. So this sun field current as well as the load current. Here is a terminal. So this current will come here. So here is it is a junction. It is divided into two. So this current is load current. This current is sun field current. Okay. So if you find this load current and sun field current, then you have to add these two values, you get the total current. Okay. First I am finding the load current, IL, which is equal to V by R. So I know the voltage, I know the current, resistance. So 240 by 50, I get the load current. Similarly, for finding the sun field current, so I know the voltage, I know the sun field resistance, V by R sketch, 240 by 240, it is 1 amps. So I know the current IL, I know the current IS sketch. So when you add these two currents, I get the load current, armature current, IA. So IA equal to IL plus IS sketch, 16 plus 1, 17 amps. So after this, I have to find the generated EMF. So the generated EMF is pi Zn by 60 into P by A. But the pi is not given. So I cannot use that formula. So I go for another method. So here 240 volt. So this 240 volt is generated by this generator. Plus here there is a resistance RE. This will cause a voltage drop. Okay. That voltage drop is IARE. So 240 plus IARA is the generated EMF here. So EG equal to V plus IARE. Okay. EG equal to V plus IARE. That formula is used. EG equal to V plus IARE. 240 plus 17. IA we have already found 17. RA is given 0.28. Multiply, you get 244.76 volt. This is a generated EMF. Now I am applying this equation. So everything is no except pi. So I am substituting that. So I am multiplying that. So I get pi equal to 0.006119 Weber. So I'm making a dot here, so it is become 6.119 milli. Okay. So after completing the sum, input, finish it, completed, we move to the next problem. Blackboard is clear. So after completing this problem, you put completed in the chat box so that I can move to the next problem. Shall I go to the next one? Shall I go to the next one? So in the problems, they mostly ask sun generator, sometimes series generator. So the common generator sums will be very rare. So they will ask you sun and series generator mostly. So in BEEE class, everyone should bring the calculator. So you have to tell the answer. So hereafter I will ask what is the answer. So next class onwards, I will ask the answer from you only. You have to tell the answer. Okay, completed. Okay, thank you. So I go to the next problem. It's somewhat different. So you know how to take the given data. So now, so I will write the problem. So you have to tell the given data. How we are understanding this problem. So the problem is a lab bound, four-pole lab bound DC sun generator, flux per pole is flux per pole is 0.08 Weber. 0.08 Weber. So the armature consists of has 260 turns. 260 turns. Okay. Each of 0.006 ohms. 0.006 ohms. So you have to find the terminal voltage. You have to determine the terminal voltage. Terminal voltage when running at 1000 RPM, 1000 RPM, and armature current is 55 amps. Armature current is 55 amps. Armature current is 55. And I will ask how you are getting the given data. One or two. You tell me what is the phi. Roll number 1 or 2. Tell me what is phi. What is phi? Phi value.
Pi value.
Given data. So I want to know the phi value. You from the sum you find out where is the pi value. You study the whole sum where it is pi. What is pi? First tell what is pi. One or two.
Sir,
What is pi? I want to know what is pi. The meaning for pi. If we know what is pi, then only we can go and see where it is. The pi is flux per pole. Okay, pi is flux per pole. Then we can easily take the value 0.08. 0.08. Okay, 103. Can you tell how many poles are there? 103. Number of
Sir,
poles.
103 is not there, sir.
Okay. So I will write down it is 4. So they are given 4 pole lab bound DC sun generator. 104.
Sir.
Okay. What is the number of parallel paths? A. In this problem, what is A? They are given lab bound. Okay. So what is A? So if it is lab binding, what is A? A equal to P or A equal to 2? 104.
P,
Tell
sir.
me whether it is A equal to P. So A is equal to 4. Okay. 106. 106. What is N? First tell what is N, then tell what is the value.
Sir, and number of
106. Ah,
260
number of?
turns.
No. It is different. I have not asked that. You see the bottom line. So what is N?
Sir, RPM.
RPM. So N is speed in RPM. So it is 1000 RPM. Okay. So next one, 107. What is armature current? IA.
Sir, 55, sir. 55 amp.
55. Okay. Now in this problem, they are given 260 turns. So here there is no conductors. They are given only turns. So we want conductors. The generated EMF we require only jet. But here they have given only turns. So in order to find the conductors, you have to multiply the turns into 2. Turns into 2. So here there is 260 turns. 260 into 2. So 520 conductors. 520 conductors. So you get the pi, you get the jet, you know the N, you know A and P. Then you can easily find the EG. You can easily find the EG. Okay. For generated EMF equation, EG equal to pi Z1 by 60 into P by A. So since you have all the values, so I can easily find the generated EMF. EG equal to pi Z10 by 60 into P by A. So pi 0.08, Z is 520, N is 1000, 60, P and A are equal 4 by 4. So you get the generated EMF. Okay. But they have asked the terminal voltage. They are not asking for EG, they are asking B. Then we have to draw the diagram. There is no way. You have to draw the diagram. If it is EG, the formula is same for every generator. So they are asked the terminal voltage. So you draw the sun generator connection. So I know the EG. So EG equal to G plus IARE. I already know this for sun generator. So if I want to find B equal to EG minus IARE. Okay. EG minus IARE. EG minus IARE. So this is the formula for terminal voltage. EG minus IARE. So IA given. So RA you have to determine. Find out the EG. If anyone having calculator, tell me the answer. What is generated EMF? What is the generated EMF? So after multiplying and division, anyone tell me the answer, what is generated EMF? I hope anyone having in the calculator, tell me what is the generated EMF. 0.08 into 520 into 100 by 6. No one? Next class onwards, you should bring the calculator. 693.34 volts. Okay, 693.34 volts. So I have all the values except Z. So Z can be found by number of turns into 2. So 260 into 2, I get 520 conductors. So after getting all the values, I substitute it and find the EG. So I draw the sum generator connection. So I know the formula EG equal to V plus IRA. The last case, same sum generator only. So I want to find B, that is terminal voltage. B equal to EG minus IARA. So IA is given. RA we have to find out. It is also here tricky. You have to think it off. So how to find RA? They have given number of turns 260. RA is 260.0061. Okay. So you have to find the total resistance first. Okay. So I am finding the total resistance in armature. Total resistance in armature. Total resistance in armature. Which is equal to 260 number of turns. So every turn as seen having 0.0064. So you have to multiply 260 by 0.0064. So you get the total resistance. So after getting the total resistance, so you have to divide by number of parallel paths. So to find RA. So RA is equal to total resistance divided by A, number of parallel paths. So whatever value here you divide by 4. Then you get RA. So after finding RA, you can apply this formula. B equal to EG minus RA. B equal to EG minus RA. EG you know. EG minus RA. EG is 693.34 minus 55 into that RA value, and you find the terminal voltage. So anyone find out and tell me what is the value here, here, and here. So a calculator is must for our subject. So total resistance is 1.56 ohm. Total resistance is 1.56 ohm. So here 1.56 by 4, you get 0.39 ohm. So RA is 0.39 ohm. So here you have to multiply by 0.39. So you get a value of 671.89. 671.89. 671.89 volts. Okay. So what I am doing is, so they have given the turns. So I have to multiply into 2 in order to get the conductors. So then I am finding the EG, because all the values, the EG formula, I know that. So I find the EG. Next I draw the connection. So and then I find the RA. In order to find the RA, you have to multiply the turns and corresponding resistance. The total number of turns is 260. Every turn has a value of 0.0064. So you multiply this, you get a value of 1.56. So in order to find RA, you have to divide the total resistance by parallel path. So total resistance by A, 1.56 by 4. So 0.39 ohm. Then you can easily substitute in this formula. V equal to EG minus IARA. Then you get the value of 671.89 volts. This is the answer they asked. So these problems are related to back EMF and the connection. So we take the same problem for a series generator. So the back EMF is same. What I am doing is, if it is a series generator, the formula will be different. You first finish this program. So after completing this problem, you put completed, so that we can move to the next. So I am taking the same problem but the series connection, series generator, so the value will be different. Is there any doubt so far? So these things you have to memorize only. Number of conductors is turns into 2. So if we want to find the total resistance, you have to multiply the total number of turns into corresponding turns per resistance. So you have to think accordingly. So every problem has its own twist. So you have to find that value. You have to solve more problems. Studying one problem and coming to exam means it is difficult. You have to solve as many different types of problems, then it will be very easy in the exam. So after completing this problem you put completed. So I will take the same problem with series generator. So last date for completing the assignment is 11th. So today is 9th. 11th is the last date for completing BEE assignment 1. So you study the material, you go through the question banks. So same type of problem will be in the assignment. So first study the question bank and then go and solve. So it will be helpful. If you have any doubt, you can call me. So depending upon the type of generator, the formula is different for the generated EMF. So sun generator means EG equal to B plus IARA. If it is a series generator, the formula is different. If it is common generator, it will be different. So depending upon the type of connection, the EG and terminal voltage formula is different. Okay. So you should draw the diagram and you can easily find the equation. Okay. So I draw the diagram and easily find EG equal to B plus IRE. Similarly, I will draw the series generator also. So while moving, the headset also moves and the voice is breaking. So I will make it tight in this class. Shall we go to the next problem? Same problem. I'm taking the same problem with the series generator. So the final equation only differs. Remaining thing are same only. Back EMF same. RA is also same. Only thing I am finding the terminal voltage will be different for series generator. Shall I go to next one? Okay, I will rub this first column since you have written this. So in a series generator, here sun field, I don't worry about the sun field because it is only parallel. If it is a series generator, terminal voltage will depends upon the series field also. Okay, so you should know the value of RSE, series field resistance. Apart from this, you should know what is RSE. The RSE should be in the value range of 3 to 5 ohms. Series field resistance. I am taking 3 ohms. Okay. Now I am drawing the diagram for series generator. Okay. This is the voltage, terminal voltage. I want to find the terminal voltage. For RSE, I have given 3 ohms. For RA, we have found that it is 0.39 ohms. RA equal to 0.39 ohms. Now, we have to write the EG. In this case, EG equal to V, this voltage. Same current flows through series field. Same current flows through IA. Okay. So I am taking as IA itself. Because IA and ISC are equal. Because it is a series cycle. V plus IA. Next, here there is some voltage drop. Here some voltage drop. So this voltage drop is IA RSC. This voltage drop is IA RA. Okay. So this is the equation for series field generator. So taking the same problem. So V is, so I have to define the V. So EG minus IA RA plus RS. So EG is 693.34. IA is 55. 55 by 0.39 plus for 3 ohms. That value minus 165. That value minus 165. So it becomes 505. 506.89 volts. Okay. So depending upon the connections, the equation for generated EMF varies. For sun generator, EG equal to V plus IARA. For series generator, it is V plus IA, RA plus RSC. So what generator they have asked in the problem, you have to see that. Then only you have to write this equation. If it is common generator, the equation will be different. For a long common generator, it is different. Short sun, it is different. So you have to clearly go through the question, what type of generator is. Then you have to write the equation. First draw the circuit. Then you write the equation. Then it will be very easy. So mostly they will ask series and sun generator only. So common generators are very rare. Okay. So this is the problems they are mostly asking here. Questions. So next we move to the next topic, DC motors. Okay. Next topic is DC motors. So write it down. So after completed, we go to the next topic, DC motors. So the pi Zn by 60 into P by A formula is, it is pi Zn by 60 into P by A is constant for any type of generator, whether it is a series or a shunt or common generator. Whatever the generator, the EG pi Zn by 60 into P by A is constant. So when you write this equation in terms of voltage, terminal voltage means you have to first draw the circuit, then you write the equation. Then only it will be correct. So if you memorize, it may becomes wrong. So first draw the circuit, then write the equation. So you can easily find the whatever voltage is required. If you want to find the voltage or you find the generated EMF. So this is about series generator. So we go to the next topic, DC motor. The construction is same only. The construction of DC motor and the generator is same only. So we go to the principle of operation of DC motor. What are the types of DC motor? How its characteristics? So in motor, speed control is very important because different applications require different speed. Some applications require varying speed also. So you have to vary the speed also. So motor is mainly used to drive the load for rotatory motion. So the speed also you have to change accordingly. Okay. So for example, I am using an electric automobile. So it has an electric motor. So if it is running at a constant speed, it is not good. So you have to vary the speed according to the needs of the road. So every motor you require a speed control. So speed control is very important in DC motors. So how to control that? So which parameter we have to change it? In automobile, it is in your automobile students. So we are varying the speed by using the regulator. How it is varied? Anyone tell? Your automobile students, tell me. So I am varying the speedometer, so varying the regulator in the hand. How the speed of the two-wheeler is varied? Anyone tell how the speed is varied in the automobile? It is not an electric motor, it is a diesel engine. How the speed is varied? Anyone? Ivan Joseph, can you tell me how the speed is varied in a two-wheeler?
Due to the throttle acceleration.
Due to the, you are giving accelerator, it goes, which parameter is controlled or which parameter is controlled? I am increasing the accelerator, okay. So inside the engine, what happens?
Yes, sir. Sir,
Do you know that or not?
Sir,
More air will flow.
Yes, sir.
More air and fuel will be flowed. Is it correct? Okay. So in electric motor, okay, thank you. So in electric motor, you have to change the current. So giving more current means it will increase the more speed can be applied. Okay. So here only current and voltages. So in electric point of view, there is only two parameters, either voltage or current. So if we increase any one, the power will automatically increase because power equal to VI. Okay. So I hope that you have completed the problem. We go to the PPT. The next topic is DC motor. Whether all of you are visible this PPT? Yes. So good morning, we have seen the construction. What are the rules? Okay. Next topic is DC motor. So DC motor will convert the electrical energy into mechanical energy. Construction is same, I have mentioned already. Same for generator as well as motor. Working principle. So when you place a current carrying conductor in a magnetic field, the force will be acted on the current carrying conductor and the conductor will displace. Here a circular conductor is placed, so it will rotate. If it is a single conductor, it will move away or move in. Since a circular part is placed inside the magnetic field, so it will rotate. Okay, so it will rotate. The force is acted on the conductor and it will rotate. Next, in motor, we are calling as back EMF. In the generator, we told that generated EMF. So in the motor, we are using the term back EMF because we are supplying a voltage. That voltage, after some losses, it is converted into mechanical energy. The mechanical energy equivalent in electrical energy we are calling as back EMF. Okay. The induced EMF in the rotating armature conductors and the EMF induced in the armature will oppose the supply voltage. Okay. This is due to the Lenz's law. So supply voltage is the input, it is the cause. The induced EMF will oppose the supply voltage. The induced EMF we are calling as back EMF. That back EMF is converted into mechanical power. So it is rotational energy. Here also, it is mainly classified into three types: shunt motor, series motor, compound motor. In the compound motor, you have two types: differential compound and cumulative compound. So differential compound means you have two field windings. The two field winding flux will oppose each other. Cumulative compound motor, two field fluxes will add each other. So in this motor, so any motor, torque is necessary. So what is torque? So torque is the driving force. Okay. If you place so much load in a vehicle, and if you start means it will not start because the enough torque is not able to drive the load. So torque is driving force. Okay. So here power equal to torque into W, which is equal to 2 by N by 60. That is angular force. So these are related to mechanical. Power equal to torque into angular force. T into this W can be written as 2 by N by 60. So in electrical point of view, power equal to back EMF into current, armature current. So I already told that back EMF is converted into mechanical energy. So back EMF in electrical point of view is EB. Back EMF is converted into mechanical power. So electrical power is back EMF into some current. The current is armature current. So EB into IA. This is electrical power. Torque into 2 by N by 60 is mechanical power. So we are equating these two. Next. So we have already know that EB equal to Kn pi n. We have derived earlier. EB equal to Kn pi n. So we are substituting that. So instead of EB, we are putting Kn pi n. So then we are taking this 2 by N by 60 here. So T equal to Kn pi n into Ia into 60 by 2 by N. Okay. So N get cancelled. 2 and 60 get cancelled and becomes 30. Pi will be there. So now T equal to Kn 30 by pi Ia. Okay. So the Kn already constant, 30 is a constant, pi is a constant. So we are removing this term and put a single constant Ka. T equal to Ka pi Ia. So torque is directly proportional to the flux. Torque is directly proportional to the armature current. Okay. The pulling power, we say in mechanical point of view, torque is known as pulling power. So this is power, this is electrical power, this is mechanical power. We are equating these two. EB we have already derived from earlier. We are substituting that equation, and we are taking all the constants into a single constant. So torque is directly proportional to pi, torque is directly proportional to I. So next here also there are some calculators. Torque, armature current calculators. Speed and armature current, speed and torque. So as I already told that speed control of DC motors is very important. So from the equation, so EB, so we have an equation, EG equal to pi Z by 60 into V by A. So instead of EB, EG we put EB. Okay. So when you put and you take the constants out, then you can return as N is directly proportional to EB, which is divided by pi. EB here, the back EMF is voltage, terminal voltage minus some voltage drop in the armature. So V minus IARA by pi. So the speed can be controlled by decreasing the flux means increasing the speed. Increasing the flux means decreasing the speed. That is flux control method. By changing the flux, you can control the speed. Okay. So next one is armature control method. So by change the armature current, so this voltage drop will be more. So I am increasing the armature current. This drop will be more. Total voltage will be, back EMF will be less. Automatically speed will also become less. If I reduce the current, this voltage drop will be less. EB will be increased. Speed will be increased. So either I can change the armature current or I can change the armature resistance also. So if I decrease the armature resistance, automatically this voltage drop will be decreased. Voltage back EMF is increased, speed will increase. So armature control method is either you can change the armature current or you can change the armature resistance. So there are two main methods. One method is flux control method, another one is armature control method. So flux control method means you can change the flux. How we can change the flux? By changing the current flowing through the field winding. So when you change the field current, the flux is automatically changes. One method is changing the field current, another method is changing the armature current. Another method is changing the armature resistance. You can also change the armature resistance in some motors. So these are the three types of control used in DC motors. So broadly classified into two methods: flux control method and armature control method. Flux control method, changing the flux, changing the field current. So armature control method, there are two methods. One, you can change the armature current or you can change the armature resistance. So flux control method. So advantages are there, disadvantages also. So advantages in flux control, it is a smooth control. So it will not cause any vibrations. Easily control. You can easily control that method. So you can get speed above the rated speed. The speed of the DC motor is 1500 means. By using this method, you can get speed above 1500 in this flux control method. So another advantage is we are using field winding resistance. It is very high in certain compound motors. So automatically the field current is small. Since field current is small, the power loss in the external resistance is also small. So it is a economical one. So power loss is minimum. So so now power is wasted in the resistors. So it is economical. These are the three advantages in flux control method. It is a smooth control, easy control, economical, and above rated speed we can. So disadvantage is, so you cannot reduce the flux. You cannot increase or decrease the flux up to a certain value. Okay. If you increase the flux to a particular value, the motor will stop. You cannot make the flux into zero value also. So there is two problems in this flux control. So if we go beyond high rated speed, high speed will affect the commutation. The commutator will get damaged. Motor operation will become unstable. So flux control, it is a smooth and easy control. You can get speed greater than rated speed. It is economical also because power loss is minimum. Disadvantage is you cannot increase beyond the rated value, and high speed will affect the commutator. So armature voltage control. So another method. So here, so the speed is directly proportional to the back EMF, the voltage across the armature. So the voltage across the armature can be controlled by variable resistance in series with the armature. Then we are varying the resistors. Okay. Here you can change the speed from 0 to the rated speed by using a rheostat. The rheostat is variable. It is connected in the armature. Okay. This method is called potential divider control method. Okay. These are the speed control we see briefly in the next class. Speed control methods. What are the speed control methods? And the categories also with the diagrams. Okay. Next one, what are the starters? In DC motor, you require starters. Why? Means the armature resistance is very low. RA is in the range of 0.39 ohms. We see in the example it is 0.39 ohms. It is up to 1 ohms. Since the resistance is low, during starting, the armature current will become very high. The starting current is 5 to 7 times of the rated current. So what we are doing is, we are increasing the resistance in the armature in the starting. So that we are limiting the current. Starting current. After the motor is started, we will gradually cut out the resistance. So there will be no problem after the starting the motor. So these starters are used to limit the starting current. So you have 3 types of starters: 2-point starter, 3-point starter, and 4-point starter. 2-point starter is used for DC series motor. 3-point starter is used for DC shunt motor. 4-point starter can be used for shunt as well as common motor. Next one, testing of DC machines. So we have to, before giving to the customer, we have to test the DC machines. So you have to determine the efficiency. For this, you should know the input and output method. Outputs. Then only you can find the efficiency. There are different methods of testing the DC motors. Load test, direct method. So in the direct method, you are actually loading the motor. So you have to give the input and you have to load the motor and you have to find the efficiency at different loads. So you should know the input as well as output of the power of the. Next one is indirect method. Swinburne test. Swinburne is a scientist who found this test. So he found an indirect method of testing the DC shunt machines. So he will take only 2 readings and he will determine the efficiency as a motor, as a generator. So here it is more economical when compared to the direct method. So every losses we can easily calculate it from the by using this method. Swinburne test is an efficient method for calculating the efficiency of a DC machine as a generator as well as a motor. So applications of shunt motor. Every motor has its own application. Shunt motor is used as blowers, fans, centrifugal and reciprocating pumps. So blowers you know, fans also you know, centrifugal and reciprocating pumps, lathe machines used for producing different components, machine tools. It is also corresponding to lathe machines. It is tools manufacturing. So milling machines, it is also a lathe machine only. Higher lathe machine will only produce a circular object. So milling machine will produce different objects. Drilling machine, it is used for putting holes in the metal parts. So everything related to constant speed applications. Since shunt motor is a constant speed motor, so these applications require constant speed. So shunt motor is used for this particular applications. Next one is series motor. The series motor have a high starting torque, so it has more driving power. So it is used for cranes to lift a heavy load, hoists and elevators, same thing only. Trolleys, so same purpose only. Conveyors to move the garments from one place to another. Electric locomotives, it is also a transport equipment only. So in order to move or lift a heavy load, you should go for series motor. Next one is cumulative compound motor. So this also have more driving torque. So rolling mills, it is used. Punches means punching machines. CS, it also tears the part. Heavy planners, it will break the objects. Elevators, lifting one. So this type of applications you can use common motors. It is more or less similar to the series motor. So we have seen the applications. So testing is two methods, direct and indirect methods. We see in the next class what is 2-point starter, 3-point starter, what are the different speed control in DC motors. So what are the categories? And we see some problems also. Okay. For next class we see some theory part and we go to solve problems in motors. So this model has two parts. One it is machines, DC machines and AC machines. DC machines first half, AC machines second half. So in DC machines you have a DC motor and generator. In AC machines you have transformers and induction motors. So in induction motors only single phase induction motor is alone is there. 3-phase induction motor or synchronous generator is not in your syllabus. Only single phase induction motor is there. Okay, it is only theory also. So the problems will occur in DC machines as well as in transformers. We see all the problems. It is simple only. So when you know the formula, you can easily put it there and you can easily calculate the value. That's all. For first model, you have to think it and you have to solve it. Second model onwards, you have theory as well as problems. Problems are only formula substitution. Okay. Gautam sir. Okay, now I will ask questions. Melvin Thomas. Melvin Thomas.
Yes, sir.
What? So echo is there. Nancy ma'am. Ma'am, Nancy ma'am, you ask questions ma'am. I have echo here.
Okay, sir. Okay. Sir, today's topic.
Whatever I taught, you ask ma'am. This is a DC motors.
Okay, sir. Okay, sir. Melvin Thomas, sorry.
Yes, ma'am.
What is the principle of Okay, what are the types of starter? Roll number 111. What are the types of starters? Roll number 111. Muhammad Ijaz. Roll number 113, Prashant. Roll number 113, Prashant.
Ma'am.
What are the types of starters?
What are the three types of starters? What are the three types of starters? What are the three types of motors? First, you tell what are the classification of motors. Prashant. I couldn't hear you. What are the 3 types of motors? Classification of motors. This time you have to write all the CA and you have to write the final exam. So you have to study the subject and you have to get marks in CA as well as in assignments and internal unit test. So you have to carefully listen the classes. Then only when studying for CA or final exam, it will be very easy. Okay. So okay, Prasad. So everyone should join the course Fundamentals of Electrical Engineering in NPTEL, and you have to send me the proof. So I will send the email ID. After joining in the Fundamentals of Electrical Engineering course, you have to send the confirmation mail to my mail ID before the next class. Friday is the next class. You have to send me the proof. Everyone should enroll. For writing the exam, we see later. So everyone should enroll for the course. You have to do the assignments. So we should know how the IIT people are teaching the class and how the IIT students are studying. For this purpose, you have to enroll this course and you have to submit the proof within Friday morning. Everyone, all the 17 students. So if it doesn't know how to go into the website, I will put a video in the evening. It's a night, before night I will put the video. Okay. So already some people have registered for some courses. That people go and register for this course also. The course is Fundamentals of Electrical Engineering. So, and you have to send me the proof within Friday morning. Everyone should enroll for this course. So we see after familiarizing with the assignments, we go, while writing the exam, we see later. In this class, if you have any doubts, you can ask me. I will stop the recording. If you have any doubts, you can ask me. Other than subject also.